Hi there. This is Jacob Nash Engineering Lessons, and this is Unit 2.1, Lesson 2, on how to do practice problem conclusion question number 1 on activity 2.1.2, which is about beam deflection. And I apologize if you watched the last video and you noticed that it had no sound. I tried to use the new iPad and it was annoying. For some reason, it had no sound. So, what things you need to do may vary based on who your teacher is, but there is already a video out there about how to do this, but it was from a few years ago, so this is an updated one. I'm not using the app Excel, but I'm using the online Excel, so it might look a little bit different from what you have. So first, you may want to put your name in cell B2. Then in cell B3, you could put the date. Or that's what date it was. And it just changes it to that automatically. Also, you're going to want to stretch out the B cells to maybe about this far. And you may want to highlight the cells. By the way, if you hold down Shift and use your arrow keys, it can highlight certain cells. Then, oh, that doesn't work, sorry. On Google products, Control-Shift-E does center aligned, but not on this one. So, there we go, center aligned. But actually, let's do left aligned. That probably looks better. On cell B5, put beam. On cell B6, put common name. On cell B7, put B for base. On cell B8, push A or type H for height. And then cell B9, orientation. Cell B10, area. Cell B11, moment of inertia. Cell B12, beam deflection. Oh, sorry, I messed up something else. Beam deflection. Now, go over to cell B or C5, type A, D5 B, E5 C, F5 D, G5 E, H5 F. Now you're going to want to do Shift down, highlight all these cells, then highlight all these cells, and this will be your table so we can make our graph. That's what this is about, doing our graph about moment of inertia versus beam deflection. So now, I usually don't do it on this one, but we need to make the cells bordered. Or actually, let's do that, all borders. Then we're going to want to do, these can stay left line, but Control B for bold. Then highlight these, Control B for bold. Also, center aligned looks better for those. We can also do this, make these center aligned but not bolded. Oh, that didn't work for some reason. Let's try that again. Oh, maybe you have to type in something first. So 2 times 6, or 2 by 6 for that one, 2 by 6, 2 by 8, 2 by 8, and 2 by 10, 2 by 10. That's the common names for these. We'll center align this later. Now the base, for this one, now this may not make sense unless you know the problem. So don't watch this if you don't even know what this is talking about. But it goes along with practice problem number 3 on activity 2.1.2. The base is 1.5. Then for this one, it's 5.5, 1.5, 7.25, 1.5, 9.25. Okay, that looks terrible. Let me see. There, that's better. Now, orientation. Now, if you remember that from the problem, I guess that just doesn't work. The reason, basically, these have the same common name, but they're different because their base and height are different. And they, I guess that did work. They're inverse of each other, if you notice that. They're the same thing, just turned in a different way, so you'll see the orientation is different. But they have the same common name, but their base and height are inversed. So this is a vertical one, and this is a horizontal one. Vertical, horizontal, vertical, horizontal. Now the area, we found out that was 8.25. Still 8.25 because all you have to do is multiply these. It doesn't matter which order they're in. They will still be the same thing. Then it's 10.875 for this one. And then same for this one. Then 13.875 on this one. Then 13.875 for that one. Now we typed in those, but we can get this thing to do the math for us, although you probably did it yourself if you did that problem. But moment of inertia. What was that equation that we did? That is going to be base times height to the third power divided by 12. So the base is in cell C7. So push equals. Whenever you're doing an operation in Excel, push equals. Push C, type C7. It knew what you're talking about. Then do asterisk. You can't push X. You have to do asterisk for times. Then C8. Then caret shift 6. That's how you get that. 3. Then divided by 1, 2, 12. Push enter. Did that. Now, what we can do is go on to C11, drag it all to these, all the way to all these. Wow. Did it for all of them. That's good. Now, do shift, highlight all these. Now, you want to, you need to change the decimal to make it only, let's see, what did it say? Let's just do 2/10. That's simple, because it's not always good to have such a big decimal. So there you go. Then beam deflection, we can do that too. The formula for beam deflection is F times L or divided by 48 EI. So what was it? We said that the F was 250, so we're saying 250 times the length. What was that? 12 feet, which means 144 inches, because remember, it has to be in inches. You need to do to third power, third. Then divide that by 48 times E, which E is going to be the, what was it for this one? 1,510,000, and then times the lost it for a second. Moment of inertia. So that's cell C11. That looks crazy, but then we push enter. Oh, nothing. Sorry, I forgot to push the equal sign. Does something. Oh, remember what I told you? You got to do it all in parentheses. So do parentheses. There we go. That's better. Then once again, drag it. Let's make that to the tenths. And there we go. Got our data. Now, don't know when this thing's going to end. If it cuts me off, sorry about that. It does 15 minutes, but I can't tell how long it's been. Unless I pause it, but then it messes up. So now we need to go to, we need to get all of our data. And the only data we need is this. Now, insert graph, scatter. Let's do scatter. No lines. There we go. We need to do title. That's required in engineering. Oh, I'm not too good with this. Sorry. Let's see. What can I do? You saw how I created the graph, so that's what you need to do. But you need to do. We need to have the axis titles, and we need the main title, the chart title. But for some reason, it's not letting me change it. It's a little bit different than on the app. Let's see. Is there like a search? There was a search on the other one. Chart tools. Let's see. Oh, maybe axis titles. Oh, chart title. There we go. Edit chart title. Okay, let's make this say deflection versus moment of inertia graph. Oh, okay. Oh, did a rotten eye with no things on. Okay, we need to do the horizontal axis. Let's make that say moment of inertia. And it needs the units, so inches to the 4th power. Remember, do that caret with shift 6. Then we need vertical axis. Change deflection in inches. And there you go. That is how you do it. Now, it said, what is the relationship between the moment of inertia and beam deflection? As the inertia increases, the beam deflection decreases. See? When the inertia was low, the deflection was high. But when the inertia is high, the deflection is low. That's what it is. Then how could you increase the moment of inertia of a beam without increasing its cross-sectional area? Well, we found out that the moment of inertia was higher when it was vertical. So if you change the orientation to vertical, the moment of inertia is way higher. So same beam, but when it's vertical, has a higher moment of inertia. That's your conclusion questions. Hopefully this helped, and remember to like and subscribe, and that will be it. Thank you for watching.